friends. Today I would like to present LEGS, the next step of studying Venus. My mission statement is to design an innovative obstacle avoidance sensor for NASA's Mechanical Clockwork Rover. Now, this isn't just any Mars rover. In fact, this rover won't go to Mars at all. This rover will go to Venus. Venus is a world hot enough to turn lead into a puddle, and the atmospheric pressure can crush a nuclear-powered submarine. We need to send a rover to that world. The bar graph on the right shows how much harsher Venus is than Earth. On Earth, for example, the average temperature in Fahrenheit is 57.2, while on Venus is 864. And for average wind speed, the average wind speed on Earth is 11.1 miles per hour, while on Venus is about 220, which makes you think you are in a ginormous tornado. I solved the problem by taking together concepts of inspiring engineers and putting together ones that would be most productive on our sister planet, Venus. What makes this idea different is that it puts more modern and convenient practices into studying the Venusian environment. What are these practices, you ask? Right here. The rover consists of three main parts: the main body, two 180-degree LiDAR units that will scan the surrounding area, and 4 legs on the bottom, each of which has a motion detector which can sense if the legs are moving or not. The legs can go on 2 different modes, bend and lock. In bend mode, you can have the main body of the rover stay at a constant altitude, and the motion sensor can detect whether or not the legs are moving due to the environment. This is often used during tamer environments. In lock mode, you can have the legs stay perfectly upright, and it will often be used as a mix of both on harsher areas such as mountains and other rocky climates. So how does this thing work? So let's say you want to move something in the environment because it is in the way. You could add a program on there that you can have the front legs bend forward and then move said object with the front of the rover. If you want to detect a hole, then you can use one of the 2 LiDAR units and see if it detects any changes in the ground, and it can detect a slope changing or a rock by having the legs in bend mode, and with the motion sensors sending a signal to the brain saying that, hey, the legs are bending, there is something here. Speaking of these legs, they can easily climb boulders up to 4'2" with the spiked tungsten wheels going up steep slopes. The technology. As a review, this rover uses 2 180-degree LiDAR units and 4 legs, each of which has a motion detector to use during bend mode. See you all, and I hope you enjoyed this presentation.